Okay, so today I want to have a look at how I can open up a text file inside of Odin and then use that file as a string within my program. Now in this directory, I have two files. The first one is the txt file that I would like to open. You can see there's nothing fancy about it. It's just a plain text file that also has a new line added inside of it. So you can see that when all this data gets read into the string will also include the new line character. Obviously, in most text renderers, that character is hidden, but it is there, and that's more for new people to programming who aren't familiar with new line characters. And then finally, the only other thing I have is a very basic Odin program just ready to go. So the first thing we're going to do is have a look at how can we open up a file inside of our program, and we do this through the core OS. So if we go over to the documentation here, you can see here is the open procedure that we want to call from the core.os package. And we can see here that open is a generalized open call, which defaults to opening for reading. If the file does not exist and the create flag is passed in, it is created with the permissions perm. And please note that the containing directory must exist, otherwise an error will be returned. If successful, a pointer to a file type is returned, which can be used for inputs and outputs. An error is returned if any are encountered. So what that means is we can use this procedure to open up a file. Now, by default, if you look at this procedure here, by default, the file will only be opened up into read mode. And that means that if the file doesn't exist, this procedure will not create it. Also, if we look into the code, into the actual code, the implementation of this open procedure. So I'm currently inside of the files that come along with the compiler. This is inside of the OS directory, and this is the file.odin, the Odin file. We can see that open is simply a wrapper around another procedure by the same name, but this is obviously a lower level procedure that will most likely be the one that communicates with the operating system to actually open this file up for us. And we can see here that inside of this procedure, it has three parameters. It has a name. This is the name of the file that we're going to pass in. In this case, it will be the text.txt file. Then it has flags. And by default, the file flag is set to read, meaning that the .txt file inside of the program will be opened up into read mode, which means our program will have permission to read to this file, but not write to it, not create it, or truncate it. And finally, there will be permissions set to default. Now, the permissions and the flags are a bit confusing if you're new, because you're thinking, well, the permission here is already read, so what are these permissions? These permissions here do not refer to the file as it's being used by our program. The file flags dictate what permissions our program have to do with it. In this case, it is read. These permissions are for if the file is created. Remember over here in the documentation, it says it is created with the permissions perm. So these default permissions over here. What that means is if I open up another terminal window and I just do an LSL, you will see all of the files in my home directory, all my files and directories. And you will also see here that we have the file permissions on the side. These are directories with read, write, execute, read, execute, read, execute. And those are the default permissions for a file, at least of my Linux setup. And when it says that the permissions perm will be used, these permissions will be the permissions that are applied to the file inside of your Linux operating system and not your program. So I'll close that now. And we can also see that if we did want to create a file, if this .txt file didn't exist, we were wanting to build a file as our program goes along, there is another procedure called create just above this one. And we could call this one just the same as open. However, it only takes in one parameter. And if we look at it, this create is actually just a wraparound open, which in turn is a wraparound this lower level open. But a lot of the parameters have already had their values falsed. You cannot edit the file flags and you cannot change the permissions. And in this case, the read, write, create, and truncate permissions are set in the file flags. That means that this new file pretty much has every permission applied to it. You can read from it, you can write to it, the program will create it, and it will also truncate it. And now that is very important to know, because if we, sorry about that, I thought I turned that alarm off. If we truncate a file, what that essentially means is the file will be opened up and all of its contents will be deleted. So if you have an important file that you just want to append to, you don't want to delete it, you just want to add to it, and you have truncated that file, you will essentially delete the file and create a new file of the same name. So only use create if A, you are making a brand new file, or B, you are making a temporary file inside of your program. So it doesn't matter if each time the program loads up, if that file gets overwritten and all the data gets lost from it. Now, what we'll do is we will take this procedure here and we'll just dump it into our program. And then we'll actually see how we can go about opening up a file with it. So I'll just paste it in right now. And we'll go back to the beginning of it. So the first thing is that it comes from the OS package. So I need to do os dot. And the next thing is we're not defining a procedure or creating a new one. So we want to get rid of that bit of syntax there. And we can then go ahead and set all of these parameters. So we want to say that name is equal to txt. Oh, sorry, text.txt, because that is the name of the file that we want to open. And then as we are not creating a new file, what we could actually do is just get rid of all of these. There's no need to set the flags and no need to set the permissions. We already know that we just want to read this file, and we know that the name of the file is going to be the text file. Alternatively, if you really wanted to limit down on this, you can also just do that and just say read the .txt file, as the other two parameters already have default values associated with them. Then we see here we have the return types. There are two things that get returned. There is the pointer to the actual file type, and that will be a pointer referring to this text file. And then finally, there is a error that gets returned to us. And errors are also a type that are defined within the operating system package. So if we go to the top over here, we see here the very first thing inside of the types is an error. And we can see here that there's also a constant related to error called error none. And we can use that to see if there were any issues with actually opening up this file. So what we'll do is we'll delete these return types because we're not making a procedure, we're actually using it. And we'll go to the beginning and we will then create the objects that we want these values returning into. And in Odin, it is important to note the order of the return types. We saw it was file, then error. That means that is how those are going to be returned from the procedure. First, the file type, the pointer to the file type is going to be returned, and then the error type is going to be returned. So the first thing we want to do is get the file, and then finally, if you did not want to actually use the error, you just wanted the file, you could do this. This little underscore here tells Odin that you would just like to ignore that particular return type, but in this case, just for practice, we want to actually handle the error value, although we know because it's such a small example, there's not going to be an error. We've seen that the text file does exist. And then if you're getting the error returned, most likely what you're going to want to do is you want to use the error. You want to actually see was there an error and then proceed. So what we'll do is we'll say if error, and remember that there was this constant value right here. What we can then do is not equal to OS, because this constant lives inside of the OS package. OS or none, I believe it was. So if it doesn't equal non-error, that means that there was an error. And what we can do is we can just say fmt.print. And I believe Odin is very good. And it already knows how to format these error objects for us. So if we just do print error like this, then we should actually see it just tell us what the error was. And we can test that right now, actually. What I'll do is I will rename the text file. And I'll just take the T out of the text file. And then we'll compile this program and run it. os.error none. I've spelled error wrong. Always got to at least spell one thing wrong. So if you get your syntax correct and your spelling is right, you will see here that we did actually get an error. And the format package, because it's set up to work very well for already all the built-in types that already exist within Odin, it just tells you the error was the file did not exist. So if we do mv now and I take that file and I rename it to text file like that, and then we go back inside of Odin, Neovan, and then what I'll do is I'll just do a little else if that did actually happen. If there wasn't an error, maybe you would like to inform the user, or maybe he's informed some type of logger that print line, text.txt was opened. So now maybe there's some logging somewhere in your program that does inform that, hey, the file was created successfully, or wasn't created, sorry, it was opened successfully. We run that and we'll see that text.txt was opened. So how do we now go about getting the data from that file as a string inside of our program? And we'll go ahead and look at that now. We'll go back into NeoVim and then we'll jump over to the documentation. And inside of the documentation, if you scroll down, you will find, I'm actually going to look for this. If I look for read, scroll down a bit. There we go. There is a read procedure already in there. And we'll read it now. Read reads up to length p of bytes from the file and then stores them in p. It returns the number of bytes read and an error, if any is encountered. At the end of the file, it returns a 0. IO, so io.efo. So it returns a end of file. And you see, read as a procedure. The first thing it takes is a pointer to a file. Remember that this is a pointer. All it is a memory address that references a file type somewhere within our program. And then finally, it also has this, and this is a storage buffer. And it reads up to length p from file f and then stores them in p. So what that means is it's going to read the data from this file and it is going to store that information into this little buffer right here, into this array of unsigned integers. And because files are just bytes of data, they are just numerics, what we can do is we can just use an unsigned integer array, so an array of unsigned bytes, to hold on to the data as a representation of that file inside of our program. And we'll do that now. So inside of here, we saw that it is os.read. And the first thing it takes is the pointer to the file. And remember, we don't need to pass in a pointer symbol here. We don't need to dereference any memory or anything. Remember that this itself is a pointer to the file that we have opened. And then finally, it takes in some type of buffer. So this procedure right here is good for, from my experience anyways, it is good for when you, the programmer, know the file that you were opening up and you know that it is a small file and you kind of know the lifetime of the file. As what we need is we need to create that buffer, and then we also need to allocate some memory from that buffer. In this case, this memory will be allocated on the stack. If this was done inside of a separate procedure outside of the main procedure, what would happen is the second that procedure gets popped off the stack, all the data in this buffer would be lost and you would lose that string. So just be wary of where you're allocating such stuff. If you're trying to wrap this around a different function and you want to get that string passed out, remember you're going to have to pass the string out at some point. But in this case, as everything's happening in the main procedure, it doesn't matter. And then we're doing a U8, an unsigned 8-bit integer. And what will happen is this file will then have its contents read, and the data of that file will be read into this buffer, and it will be read up to 256 bytes. And what we'll, 255 bytes. And what we'll see here is, first of all, we have two things being returned from this procedure. First of all, we have the integer, the number of bytes that are being read. Don't really care about that. We can ignore that, but we will get the error back. So what we'll do is we'll tell it that I'm not that interested in knowing how many values were actually read from this, how many bytes of data were read, but instead I will get a read error back. I want to know if there is an error when reading this. And then what you might think, hopefully, is great. I now have the data inside of my program. And what I want to do is I just want to print it out. And Odin is very good. And it's very good at just you passing in the objects into the format package, and it just knows how to print them out. So what happens if we do that? We'll do print line, we'll just print everything on a new line, and we'll say we want to print out the buffer right now. And another thing to note is that we need to tell it how much of the buffer it is allowed to write into. In this case, we need to pass in a slice. So we need to say, I want you to read into this buffer from this point to this endpoint. In this case, just passing in the blank slice like this. Just says, I want you to use the entire data buffer right here. If I didn't pass it in as a slice right now, I would get an error. I know that because I've made it many, many times in the past. And then if I come out of here, and then we do Odin.run, what we'll see is, yes, the data from that file was read. This is the actual data in here. If you really, really wanted to, what you could do is you go on the internet, you could look up an ASCII table, and you could then decode all of this yourself. But realistically speaking, this isn't actually what we were thinking of, was it? When I said I was going to open it up as a string, what you were expecting was the actual text from the file to show up on the screen right now. And that's because what we did is inside of the format package, while it is very good at printing out the built-in data types of Odin, it had no way of knowing that the way we wanted this information to be represented was as a string. It saw that we were passing in an array of unsigned integers, and that's exactly what it did. It printed out the array for us. And that's great, actually, to be honest, in a lot of cases. But in this case, not quite what we're looking for. So one thing we can do, and this is a very easy fix to this, is we can make a string. So text, and then we can allocate it as well. We can define, declare, and allocate, or initialize, sorry. And we can make it a type string. And one thing we can do with strings is they kind of have a constructor to them. I'm not actually sure 100% how this works. Like, I think we're just casting into a string at this. I'm not too familiar with the syntax, but I know this works. And what we can do is we can pass in the buffer, and it will cast that data of the buffer into a text. So if we remember, all a string is just a length and a pointer. And the buffer is just a place in memory that is so much long, and it has a data to it. So what will happen is, my brain's very going right now, is the string will be giving the starting memory address of the buffer and the length to it. And because we are using a string object, whenever we try to use this object here, as in we pass in the text down here, the format package will see that we're now passing in a text object that is a string. And when it reads the bytes of memory that are on here, because the string doesn't hold on to any new information, all it's doing is just pointing to the buffer, pointing to all those numbers that were already there. But now as we're passing that data in as a string, the format package then knows how to represent it the way we want. So if I go out of here and I do Odin run dot like this, you can see here that text file was opened, and then the actual data that was inside of the text file was printed out. It's now stored in our program as a string, and then we can use it any way we want. We can use it as a regular string within inside of our program. Now, this is great if we know if we know the file exists and we also know how big the file is. For example, if I was to go out of here and then instead of that, I open up the text file. And then what happens if I add in more than 255 characters? I'm just going to try and guess until I think I've reached the limit of 250 characters. I'll then just yank this and I'll paste it a few times. So now this file is clearly bigger than 255 characters. What happens if I try to read from it right now? So if we run the same program's identical, nothing has changed, and we do Odin.run, you can see that everything worked fine. Nothing bad actually happened. The text file was opened, and then we can see text has read in the same way, and then it attempted to actually read more of the file. But as you saw just then, the file actually goes on for a lot longer. However, we only allocated 255 bytes inside of the memory for this file to hold on to. So what this procedure does, it's able to see how big this buffer is, and it will only read up to P, and that was commented in the documentation. Reads up to length P of bytes from file F and then stores them in P. Now, this is also going to have thrown an error for us. So what we'll do is we will do fnt.print. We'll print the line out, and then we'll do the read error. So Odin.run. And you can see here, oh, there wasn't. That is interesting. There's a learning thing. There actually wasn't an error thrown there. I thought maybe it was the read function would have actually thrown, or this read procedure would have actually thrown an error when we try to read over it. There's a learning experience. I actually thought that what this did is if you try to read too many bytes into this buffer, that it would throw a different error. So obviously that's not the case. That's a learning thing. That's why I call these learning bugs. And I'm not trying to preach to you that I actually 100% know what's going on. But yeah, I think I'm going to end this video here because it is going on a little bit. What I'm going to look at in the next one is what happens if you want to open up a file and you don't know the length of it. What happens if you can't confidently pass in a number here and you know the whole file is going to be read? That means we're going to have to allocate memory on the heap because we won't know before runtime at the size of the file And I'm going to quickly make a video on that as my next video. But I feel like this has gone on for a bit long now, so I'll pick that up in the next one. All right, see you, and thanks for watching.